So, how do you find the domain of a function defined by an equation? I mean, if the variable in the function stands for something in the real world, there might be real world limitations on what that can be, where you can't have a negative number of people or something like that. So in a case like that, the domain might be determined by those real world limitations. But just speaking mathematically, as far as doing the calculations go, if you've got an equation that defines a particular function, how do you figure out what the domain of that function is? Here's how. And let me tell you that in this chapter, we're assuming our functions are in real numbers mode, which means they're expecting the input numbers and the output numbers to all be real numbers, as opposed to like the imaginary numbers you get when you try taking square roots of negative numbers. So in this chapter, unless we say otherwise, we're assuming that all our functions are in real number mode. The numbers that go in have to be real numbers, and the numbers that come out have to be real numbers. So to figure out what the domain of a particular function is, start with the set of all real numbers. Sometimes that's going to be the domain. If the function would work on any real number that you put into it, the domain would be all real numbers. But there's a couple things to watch out for. If the equation that defines the function has a denominator, if you've got a fractional expression with something over something else, you have to exclude any numbers that give you a 0 in the denominator. So that's the one thing to watch out for. And then the second thing to watch out for, if the equation has a radical of even index, that is, if it involves the square root of something, or the fourth root, or the sixth root, or the eighth root, exclude any numbers that cause the expression inside the radical to be negative. Since we're in real number mode, we don't want to be taking the square root of any negative numbers. So the radicand, the thing under the square root sign, has to be greater than or equal to 0. Okay, so with that in mind, let's look at some examples. What is the domain of each function? Remember what we're looking for. When it says what is the domain, that means what is the set of numbers that we are allowed to plug in for x? What numbers does this function accept as possible inputs? What works? So what about x squared plus 1? What can we do that to? Well, we can do it to any number. We can take any number at all, multiply it by itself, and add 1 to the result. So here the domain would be all real numbers. Now you can write it out in words like that. You can also use this fancy R, which is the mathematical symbol for the set of all real numbers. Or you can write it as the interval from negative infinity to infinity. So if I asked you what's the domain of this function, you could write it any one of those ways, as long as I know what you're saying. What about this function? F of x equals 3x cubed minus 7x squared plus 17x minus 200. So start with the set of all real numbers. And then the two things we have to watch out for are denominators can't be 0, and anything under an even indexed radical has to be greater than or equal to 0. But we don't have either of those things going on here. Do you see any denominators? No. Do you see any radicals? No. Then there's nothing that would cause us trouble. Nothing that would cause this function to break down. So the domain here is all real numbers. Okay, what about this one? F of x equals 1 over x minus 3. Now this one does have a denominator. So we have to exclude any x's, any numbers that if we put them in for x, we would get a 0 in the denominator. And what number would that be? 3. So the domain is all real numbers except 3. We can't put in 3 because we get a division by 0 error, but we can put in anything else. So the domain for this function is all real numbers except 3. What about this function? F of x equals x minus 1 times x minus 2 over x times x minus 3 times x plus 4. Remember what we got to watch out for. Any x's that would give us a 0 in the denominator have to be excluded from the domain. Okay, which x's would those be? Well, for the denominator to be 0, that would happen when any one of the factors that make up the denominator is 0. So it would happen when x is 0, or when x minus 3 is 0, which is when x is 3, or when x plus 4 equals 0, which would be when x is negative 4. So those are the bad x's. So those are the ones we want to stay away from. Don't put any of those numbers into your function. So the good x's are everything else. The domain there is all real numbers except 0, 3, and negative 4. Notice, by the way, that it's okay for the numerator to be 0. If we get a 0 on top, 0 divided by something else, well, that just comes out to be 0. That's okay. There's nothing wrong with that. It's just that we don't want the denominator to be 0, because if we have some other number divided by 0, that's undefined. So the domain here is all real numbers except 0, 3, and negative 4. Oh, and by the way, up here I have another way of writing the domain for this function. The fancy mathematical way of saying all real numbers except 3 is to say it's the set of all x in the set of real numbers such that x is not equal to 3. So if you're familiar with that set builder notation and you want to use that to write your domains, you can. If not, you don't have to. Just when you write what the domain is, whether in words or in symbols, as long as you're clear about exactly what you mean, I'm not going to be picky about exactly how you write that. Okay, what about this function? F of x equals x minus 4 over x squared minus 10x minus 11. Remember what we have to watch out for. We need to exclude any x's that would make the denominator 0. When would that denominator be 0? Well, that kind of looks like a quadratic equation. We can solve that one by factoring. That factors into x minus 11 times x plus 1, because if you multiply that out, you get x squared plus 1x minus 11x, so there's your minus 10x, minus 11. And then for x minus 11 times x plus 1 to equal 0, either x minus 11 equals 0 or x plus 1 equals 0. So x equals 11 or x equals negative 1. So is that the answer? Well, not quite. Remember, the question was, what's the domain? What is okay to put in for x? These are the x's that are not okay. So the ones that are okay are everything else. The domain is all real numbers except 11 or negative 1. Okay, how about this one? F of x equals the square root of x. So this function takes whatever number you give it and gives you the square root of that number. Now remember, we said we don't want to be taking square roots of negative numbers because we're in real number mode. So the x here has to be greater than or equal to 0. It's okay if x is 0. We can take the square root of 0. That would just be 0. And we can do the square root of anything bigger than 0. We just can't do the square root of anything less than 0, because then we'd be looking at the square root of a negative number, and that's undefined if we're just working with real numbers. It would get us into imaginary numbers involving I. So for the domain here, we'll say it's all real numbers greater than or equal to 0. You can write that out in words, We can write it as an inequality. X has to be greater than or equal to 0. Or we can say it's the interval from 0 to infinity. Notice the square bracket by the 0. 0 is included. We are allowed to plug in 0 itself. And we're allowed to plug in anything bigger than 0. What about the next one? F of x equals the square root of x minus 2. Here, the thing that we're taking the square root of, the x minus 2, that has to be greater than or equal to 0. So that means, adding 2 to both sides, that x has to be greater than or equal to 2. So the domain is all real numbers that are greater than or equal to 2. That is everything from 2 on up to infinity. What about if f of x is the square root of 9 minus 3x plus 2? Now careful, notice how far out the radical sign extends. The only thing we're taking the square root of is the 9 minus 3x, not the plus 2. So it's the 9 minus 3x that has to be greater than or equal to 0. It can't be negative, it can't be less than 0, so it has to be greater than or equal to 0. It's okay if it's equal to 0, it's okay if it's positive, it just can't be negative. Okay, so what does that tell us about x itself? What numbers are we allowed to put in for x and do this kind of thing to them? Well, let's solve this for x. If I subtract 9 on both sides, I get negative 3x is greater than or equal to negative 9. And then to go from negative 3x to just x, I can divide both sides by negative 3. And remember, when you divide by a negative number, you reverse the direction of the inequality. So x is less than or equal to positive 3. So the domain, the set of numbers that we are allowed to plug in for x, would be everything that's less than or equal to 3. It's okay to plug in 3. It's okay to plug in 2 or 0 or negative 10. We just cannot plug in anything greater than 3. Can't plug in 4 or 5 or 12. So the domain here is everything from negative infinity up to and including 3. Now what about if our function is the cube root function? Takes whatever number we give us and gives us the cube root of that number. There, the domain is back to being all real numbers. It's okay if x is negative here, because we can take the cube root of a negative number and we just get another negative number. So here x can be anything, positive or negative or 0. So the domain is all real numbers.